Which of the following definite integrals represent the length of the curve defined by f of x equals x squared on the x interval 0 and 3? So to solve this question, first we have to write the formula. So what does the formula says? S is the arc length. So the arc length equal to the definite integral from a to b square root of 1 plus f prime of x squared x squared then dx. So f prime of x can be written as dy over dx. So we're going to write instead of f prime of x squared dy over dx squared. Dx. So here we have f of x equals x squared. Okay, so if f of x equals x squared, f prime, which is the derivative of x, is going to be equal to 2x. So how was it 2x? So here we're going to move the 2 here, and 2 minus 1 equals 1. So 2x. So then f prime of x squared equals to. So this is, we're going to put 2x the same, but we're going to add squared. So 2x squared. So we're going to have 4x squared. So now we're going to use it in the formula. So the arc length equals to. So now we have the point A and B. How will I find the point A and B? Here we have, this is A and this is B. So the point A, which we had here, 0, so 0, and the point B, we have it here, 3, so 3. And now, as the formula, square root, so the one is going to be the same as the formula, plus. So we find dy over dx, which is 4x squared, dx. So the definite integral from 0 to 3 of the square root of 1 plus 4x squared dx. So the answer will be B. The length of the curve y equals x to the power of 3 from x equals 0 to x equals 2 is given by. So to find the answer, we have to use the arc length formula. So what does the formula say? S, which is the arc length, equals to the definite integral from a to b square root of 1 plus dy over dx squared dx. So if y equals x to the power of 3, what does y prime is? So y prime is the derivative. So we're going to find the derivative. So y equals x to the power of 3, we're going to find the derivative. So y prime equals. So I'm going to move the 3 here, So 3x, and then 3 minus 1 is 2, so 3x squared. So y prime equals 3x squared. So now we find the y prime, which is the derivative, and now we're going to put it squared as the formula. So dy over dx squared is 3x squared. Then, as we can see here, we're going to use squared. So how to find the answer? So I'm going to use the squared one time with the 3 and the other time with x squared. So 3 squared and x squared bracket squared. So 3 squared equals 9. And then x squared, then bracket squared, so multiply together, going to have x to the power of 4. And now we're going to use it in the formula. So here we have the arc length, so S equals. So the definite integral between a and b, how to find that? Here in the formula it's given. So x equals 0 is a, and x equals 2 is b. So definite integral, as we find here, a is 0 and b is 2. Then square root of 1 plus, as we find the derivative here is 9x to the power of 4, as you can see. So 9x to the power of 4 dx. So the definite integral between 0 to 2 of square root of 1 plus 9x to the power of 4. So the answer will be E. Which integral gives the arc length of the curve y equals e to the power of 3x over the interval 0 and 2? So I'm going to write the arc length formula. So the arc length equals to definite integral between a and b square root of 1 plus dy over dx squared dx. So now I'm going to find the derivative of y equals e to the power of 3x. So we know that the derivative of e to the power of x is the same. So I'm going to find the derivative of 3x, which is 3. Then I'm going to keep it the same as it is. So e to the power of 3x. So now I'm going to write derivative squared. So dy over dx, which is derivative squared. So we find the derivative, which is 3e to the power of 3x. And I'm going to put it squared. And now I'm going to multiply it by, I'm going to use the 2 with the 3 and with the e to the power of 3x. So 3 squared and e to the power of 3x squared. So 9 squared equal 3 squared is 9, and then I'm going to use the e to the power of 3x multiplied by 2, so e to the power of 6x, because 3 multiplied by 2 is 6, and I'm going to keep the x. Now I'm going to use it in the formula. So the arc length equals to the definite integral. So we have here 0 is a and 2 is b. So a is down, which is 0, and then we have b is 2, then square root of 1 plus. So we find the derivative squared, which is, as we can see here, 9 e to the power of 6x dx. So the definite integral from 0 to 2 to the square root of 1 plus 9 e to the power of 6x dx. So the answer is C. Which integral gives the length of a graph y equals square root of x between x equals a and x equals b? So the arc length formula. So the arc length equals the definite integral between a to b square root of 1 plus dy over dx squared, which is the derivative, dx. So now we need to find the derivative. So y equals square root of x. So because we have square root, we can't just find the derivative directly. We have to rearrange it. So derivative of square root of x is x to the power of half. So now we can find the derivative as the power rule. So y prime equals. So I'm going to move the half here. So half x. So half minus 1 is negative half. And now I'm going to use the derivative squared, which is dy over dx squared. So I'm going to keep the half same as it is, so half. Then we can know that x to the power of half is the same as the square root of x. So because we have here negative, so the square root will be down. So square root of x. Because as we can know, square root of x is the same as x to the power of half, and x to the power of half is the same as square root of x. But why did I put the square root down? Because here we have negative, so it has to be down. And then I'm going to put it squared. Then 1 over 2 squared is 4. Then because we have here squared, the square root will go out, so no square root, so 4x. And now we can put it the same as the formula. So the arc length equals to the definite integral between a from a to b, then the square root of 1 plus, as we find the answer here, 1 over 4x dx. So the answer will be D. What is the length of the arc of y equals 2 over 3 x to the power of 3 over 2 from x equals 0 2x equals 3. So first let's write the formula of the arc length. So the arc length equals to the definite integral between a to b square root of 1 plus dy over dx squared dx. Okay, so for now we're going to find the derivative. So y equals 2 over 3 x to the power of 3 over 2. So I'm going to multiply 3 over 2 with 2 over 3 is going to give us 1. So we don't need to write it. So I'm going to just write x. Then 3 over 2 minus 1, which will give us half. Okay, now, as we can know, x to the power of half is the same as the square root of x. And square root of x is the same as x to the power of half. So I'm going to write the y prime squared, as we can see here. So y prime squared and y over dx is the same. So it's the same derivative. So now, because it's squared, so the square root will going to go out. So it's going to be x. And now I'm going to do it as the same as the formula. So the arc length equals to the definite integral from 0 to 3. So how did I bring 0 and 3? As we can see here, x equals 0 is a, and x equals 3 is b. Then square root of 1 plus. So we find the derivative, which is x dx. And now I'm going to put this number, this whole formula in the calculator.
So how to find the arc length formula in the calculator? So this is the arc length formula, and then I'm going to put square root 1 plus x as we solved it in the formula. Then down was 0 and up was 3. And this is how we find the answer.
After using the calculator, we have an answer of 14 over 3.